The weekly update for Mr. Fix's science class for the week of December 13th. All students at Springview on Monday took the California Healthy Kids survey. We also passed out Homeschool Connection number 3, and that was due on Wednesday. So students had to check the boxes about what they thought about motion and forces, and then they had to explain their thinking, 2 sentence minimum to get full credit. Then they had to go home and ask the person at home what they thought, which ones they agreed with. Then they had to paraphrase their thinking, the other person's thinking, in their own words, 2 cents minimum to get full credit. So that was collected on Wednesday for 10 points. We did force and motion lesson 1.5 over Tuesday and Wednesday. We also added to the force and motion unit guide and also push mo, pull mo. So let's take a look at that. So we added the direction of the forces exerted on Mo and labeled which objects exert those forces on Mo. So we did number 3, 4, 5, and 6 this week. We did 1 and 2 last week. We added to the force and motion unit guide, page 21. We completed the whole page. Then on page 22, we did question number 2 and key terms of mass. Then on Thursday, we did lesson 1.6, including 1.6.3, explaining thruster forces. We did a modeling activity on Amplify, and we copied this down to help us answer the question. So most pods, when they're traveling toward the space station, have this velocity. Normally, the thrusters exert a force with this strength into that direction, causing the pod to stop. Claim 1 was saying that the thrusters exerted a force that was stronger, or exerted a force that caused the pod to reverse direction. Claim 2 was the thrusters exerted a force to cause it only to slow down. So claim 1 was a bigger than normal change of velocity, and claim 2 was a lesser than normal change of velocity. So the only way that could have happened is if a stronger than normal force by the thrusters were exerted on the pod, and claim 2 is only happens if a weaker than normal force happens on the pod. That's what they had to do here, was write those things in using that modeling tool. We also did the challenge statement. Beaker's not moving because there are no forces exerted on him. So they had to state if they agree, disagree, or kind of disagree with that. They explained why they agreed, disagree, or kind of in between using sentences. We then drew and labeled the forces that are acting on Beaker. So actually there is Earth pulling on Beaker with that strength force downwards towards Earth. And the reason why Beaker's not moving downwards is because there's a board pushing upward on Beaker with the same strength force in the opposite direction. So balance forces cause no change in direction. And that's what we wrote down there. So there are forces acting on Beaker even though Beaker is not moving. So that was added to the reference notebook. And then finally, we did lesson 2.1, force and motion lesson, and then we did the Edpuzzle Why Are Astronauts Weightless. We also looked at Beaker. We apply a certain amount of force and Beaker's velocity changes that amount. Then on a different surface, we apply the same force on Beaker and he has a greater change of velocity. So